This is section 6.6.1, FOIL and factor. Before we get started, we need to understand polynomials. First, a monomial is an algebraic expression with one term. Our examples are 2x, 5y squared, and 7. These are each monomials because there is only one term. A binomial is an algebraic expression with two terms. For example, x plus 3 is a binomial because it has two terms, x and positive 3. 2x cubed plus 4 is a binomial because it has two terms, 2x cubed and plus 4. And finally, a trinomial is an algebraic expression with three terms. Our example here, x squared plus 3x minus 9. You can see it has three terms, therefore it is a trinomial. Next, we're going to review the distribution property. As you already know, when we multiply something by a quantity in parentheses, we need to distribute the coefficient out in front. So in this case, we're distributing the a to end up with ab plus ac. Now, if what's in parentheses has more than just two terms, nothing really changes. We have to distribute to all three terms. So in this case, we end up with ab plus ac plus ad. Now, when we multiply polynomials, we are in a sense using the distribution property. In our first example here, we take our x and we distribute it to both terms in the next polynomial. So we end up with xb plus xc. Then we have to distribute the y to each term in the next parentheses. So we have plus yb and plus yc. If one of the polynomials has more than two terms, it doesn't change anything, we're still distributing. So down below here, we would have to distribute the x to each term in the next polynomial that we're multiplying by. So we would have xb plus xc plus xd, and then we would go ahead and we would distribute the y to each term, and we would have plus yb plus yc and plus yd. Now, what we want to talk about is how distribution is really the same as the FOIL method. You might remember the FOIL method from previous classes. FOIL stands for first, outer, inner, and last. And what I want to do is I want to show you how these are the same things, meaning distribution and the FOIL method. So up top here, we're going to use distribution, just like on the previous slide. We're going to distribute the x, and then we're going to distribute the y, and we're going to end up with xb plus xc plus yb plus yc. Now, in our second example, you can see it's the same thing. We're going to use the FOIL method. So first, F stands for first, meaning we are going to multiply the first term in each binomial. So the first term in our first binomial is x, and the first term in the second binomial is b. When we multiply those together, we get xb. Next, we have O for outer. So the outside terms occur on the outside of the two binomials. So what we have here is we have x times c. So in this case, we're going to get a positive xc. Next, we have I for inner, meaning the inside terms of the two binomials. So we're going to multiply y and b to get positive yb. And finally, we're going to multiply the last terms, L for last. Last term in that binomial is y, and the last term in that binomial is c. So we will multiply those together to get positive yc. So what you can see here is that the distribution property and the FOIL method give you the exact same result. We often refer to the FOIL method instead of distribution when we are multiplying two binomials together, which is what we're doing here. Remember, x plus y is a binomial because there are two terms, and b plus c is a binomial because there are two terms. So here's some practice of multiplying polynomials. In our first example, we have a monomial times a binomial. And all we need to do is distribute. And we come up with 6x squared plus 14. Remember that 2 times 3 is 6, and that x times x is x squared. In our second example, we're multiplying two binomials together. So if you want, you can think of this as the distribution property or the FOIL method. I'm going to think of it as the FOIL method. So when I multiply my first terms together, I'll multiply 4x times x and get 4x squared. Next I have O for outer. So my outside terms, remember, outside terms will be 4x and positive 2, and that'll give me a positive 8x. Then I in FOIL for inner, I'll multiply negative 1 times positive 2, negative 1 times positive x and get negative x. And then finally L in FOIL for last. So the last terms are negative 1 and positive 2, and that'll give me negative 2. Now when I do this, I notice that I have like terms here in the middle. I have two x terms, and I always want to combine like terms when possible. So in this case, I'll have 4x squared plus 7x minus 2. In number 3, we have 5 times the quantity, x squared minus 5x plus 4. In this case, we're simply going to distribute. We will end up with 5x squared minus 25x plus 20. And in number 4, we're multiplying a binomial, 3 minus 6 has two terms, times a trinomial, 3y squared plus y plus 1, 3 terms. So in this case, we need to distribute. First, we're going to distribute the 3y to each term in the second trinomial. So 3y times 3y squared, 3y times y, and 3y times 1. So I'll end up with 9y cubed plus 3y squared plus 3y. Next, I have to distribute the negative 6 to each term. So I start out with negative 6 times 3y squared, and I get negative 18y squared. Then negative 6 times positive y gives me negative 6y. And finally, negative 6 times positive 1 gives me negative 6. All that's left to do is combine like terms. I can see that I have 2y squared terms, so I can combine those. To get negative 15y squared. The 9y cubed was the only y cubed term, so I leave that alone. I also have two y terms that are like terms, there and there. So 3y minus 6y will give me negative 3y. And finally, the minus 6 on the end is my only constant, and so that remains minus 6. So it's important to remember that distribution is really the same as the FOIL method, but it's this number 2 example right here that when we're multiplying two binomials together, oftentimes we refer to the method to multiply those together as the FOIL method. First, outside, inside, last. That brings us to factoring. Factoring quadratic expressions. Factoring a quadratic expression is the process of writing the expression as the product of two binomial expressions. So first, let's review a quadratic. You'll probably remember that a quadratic is any expression that has an exponent of 2 in it as its greatest exponent. So ax squared plus bx plus c is not only a trinomial because it has 3 terms, 1, 2, 3, but it's also what we call a quadratic expression because the largest exponent is a 2. You'll notice in the definition here that factoring a quadratic expression is the process of writing the expression as the product of two binomial expressions. So really what we're doing is we're working in the reverse of the FOIL method. Let's go back here for 1 second. The FOIL method that was used in number 2, we started with two binomials and we ended with a quadratic. Well, now what we're going to do when we factor is we're going to start with the quadratic and we're going to end with the two binomials. So how do you do this? The first thing you have to do is to determine the signs of the two binomials. There are some set rules for doing this, but there are also a lot of different ways to be taught how to factor quadratics. This is the method that we're going to learn in this class. So first what you do is you look at the second sign of the quadratic. Now the second sign of the quadratic is right here. So if you read the quadratic from left to right, we have our second sign. If the second sign is positive, then you look at the first sign, right there, and you put it in both binomials. So if the first sign is positive, you put two plus signs in the binomials. If it's negative, you put two negative signs in the binomials. Now, if the second sign is negative, automatically put one positive and one negative sign in each binomial. These rules should make more sense as we go through our examples. So let's take a look. On this page, we have 3 examples where we're factoring quadratics with a equaling 1. A being the coefficient of the squared term. So you'll see that here in our first example, it's 1x squared plus 6x plus 5. In our second example, it's 1x squared minus 6x plus 8. And in our third example, it's 1z squared minus 5z minus 24. So these are generally easier quadratics to factor. So let's go ahead and do this. We always start by setting up parentheses for our two binomials. And now it's time to assign the signs, positive or negative. So let's apply our rules. We look at the second sign first, and in this case, it's positive. So according to our rule, we look at the first sign, and whatever it is, it's going to go in both binomials. Now we can factor by doing the opposite of FOIL. Remember with FOIL, F stood for first. The first term in each binomial multiplies together to get x squared. So let's factor x squared into x and x. Remember, the L in FOIL stood for last terms. We multiplied the last term in each binomial to get the final constant of the quadratic. So now we're going to factor the 5 to get the two numbers that go in our binomials. And in this case, 5 times 1 is 5. Now when we factor, we always want to check by FOILing, because not only does the 5 times 1 have to equal 5, but it has to add up to the 6x, because remember, FOIL had the outside-inside as well. So the outside-inside has to give you this middle term of positive 6x. So let's make sure by FOILing. First, x times x would give us x squared. Outside, x times 1 would give us positive x. Inside, 5 times x would give us positive 5x. And last, 5 times 1 would give us positive 5. Now we combine our like terms. X plus 5x is 6x. And you'll notice that when we FOIL, we end up with the exact quadratic that we started with. This tells us that our factors of x plus 5 and x plus 1 are correct. Let's look at our second example. We start by setting up parentheses for our two binomials. We look at the second sign. It's positive, so we look at the first sign, and whatever it is, it goes in both binomials. Factor x squared to x and x, and then factor 8 so that the outside-inside combine to give us a negative 6x. Well, this is where it gets a little more tricky. 8 has factors of 8 times 1 and 4 times 2. So do we want to choose the 8 times 1 or the 4 times 2? We want to choose the 4 times 2. Because 4 times 2 is 8 and 4 plus 2 is 6, so when we FOIL, we'll come up with what we originally started with. First, outside, inside, last. Combine like terms. That quadratic is exactly what we started with, so we can be confident that our factors of x minus 4 and x minus 2 are correct. Let's look at one final example with a equaling 1. Set up our parentheses for our binomials. Now in this case, when we look at our second sign, it's a negative sign. That means that we're going to automatically have one positive and one negative sign. Factor z squared into z times z. Factor 24 so that we can end up with negative 5z as our middle term. So we have to think a little bit here. 24 times 1 is 24. 12 times 2. 8 times 3. 6 times 4. All of these are factors of 24. Which do we choose to use? Well, we can pretty much eliminate 24 and 1 because there's no way we're getting negative 5 out of those. 12 and 2 is not going to end up giving us negative 5 either. 8 and 3, well, 8 minus 3 is 5. So if we put the negative 8 and the positive 3, and then we double check by FOILing, first, outside, inside, last, combine like terms, we get exactly what we started with. So we can be sure that our factors of z plus 3 and z minus 8 are correct. So that gives you a good overview of FOIL when it's used to multiply two binomials together and factoring quadratics into two binomials. This has been section 6.6.1 on FOIL and factor.